We just started the recording, so as we see from the first time and from your feedback in emails, we are very glad and happy to hear that that it was interesting to you. We will try today to put in all the suggestions that you were sending us. So examples also from Montenegro. But for not being too long at the beginning, maybe Luca, if you just give us the next slide. As you know about the project, this is part of the project which is funded by the Slovenian government, and the idea is to bring the ideas of Tourism 4.0 to Montenegro, so experiences that we gained in Slovenia. Please just go on. And one of the wishes and question was if you will receive a certificate. Yes, don't worry. At the end of the webinars, we will make a short questionnaire. So for everyone who has followed all the parts of all the webinars, it will be an easy exercise for you to reply to that, and then you will receive a certificate. And I would say now, Mateusz, I will give the word to you. But before that, yeah, this is one more information. We have more webinars coming, and next week will be an exciting one together with the municipality of one of the locations where we are working. But Mateusz, maybe do you want to tell us more about that?
Yeah, maybe just a bit of a context. So last time, hello everyone, by the way. Last time we showed you, let's say, inspiration. We showed you some projects that we did, but not in detail, and of course not explaining how things were done. Today we are starting discussing how things are done, starting first with 3D digital capture and data processing. That will be followed in next sessions with more content on the digital storytelling, data management, and of course at the end a hands-on workshop. But today, as said, we will be discussing 3D digital capture and data processing. Here with me are two of our experts who were also in Montenegro 2 weeks ago. Luka Vodopivec and Jernej Kalin. They both work in our 3D team, and both of them have been engaged in several projects across Slovenia. Basically, most of the projects that I have shown you last time, they were the ones who were part of the team. So I'm happy to introduce Luka and Jernej. Luka and Jernej, welcome. And I suggest you start and present us this topic. So we will split the session in 2 parts. The first part will be covered by Luka on 3D digital capture, and then Jernej will explain the data processing. And at the end, hopefully we have some time for some of your questions and some of the suggestions also for the next time. Luka, yes. The floor is yours.
Okay. Natasha, excuse me, can you open my camera? Because I think you closed for me. Yes. Okay. Here I am. Okay. Yeah. As Mateusz said, me and Jernej are 3D artists working at Arctur, and we will talk about the photogrammetry, taking photos of objects which we want to scan, and in this presentation we will cover the methods of 3D of scanning 3D models, the process on the field, and the process on software where all this data you collect, you process and make 3D model. Okay. We know 2 most common ways to make scans. One is with laser scanning, and the other is with photogrammetry. Laser scan uses beams to capture the points of the surface. Sometimes they do it twice to check if it's correct. And the laser scan, these are the scanners. We have different scanners. Mostly they move the head, and so the beams connect all the space, capture all the space. And at the end, we got the point cloud, which is the points they collect, and there are each point has data of color and the place in the space. With laser scanners, we got really high quality scans, but the problem is they don't have the textures. They are just colors. This is another one, the laser scan. And the second one, which we will cover today, which we use the most, is photogrammetry. This is the scanning with photos. For photogrammetry, we mostly use drones and photo cameras. Depends, we split what we want to take. With drones, usually we take the large fields and the large objects, while with cameras, we cover the parts which drone cannot cover, we don't see, and after that we merge both data together. This is the example of the point cloud, which is created by photogrammetry. Photogrammetry software they are spreading like mushrooms, we can say, because it's getting really popular. Today you can scan also with your smartphone, but this one are let's say the pro ones, where you can get really decent model at the end to use it in some software applications and viewers, online web viewers. In photogrammetry, we have some terms that are really used. That's like, let's say, like markers, key points, aligning. All these terms will be used later in explanation. I will not cover each one because we can be here for all day. The process of photogrammetry really starts at the office. When you know what you will scan, you check the environment where it is. If it's near the airport, there are some restrictions. Also, the restrictions are the weather, of course, the wind, the vegetation, and you must plan in advance to clean everything, because whatever you will photograph, it will be later on the 3D model. So the preparation really starts at the office. If you know that you will use drones for capturing, you must consider the airport, because there is in European Union is the rule that from the center of the airport, the radius 5 kilometers, it's not allowed to fly freely, so you must request some authorization. For the authorizations, you must be registered as operator, as a drone operator, and you have to have the certificate for flight, the proof of training, online training, like license. There are some things, usually you check the CAA, this is the Agency of Aviation. let's say in Montenegro, we went on CAA.me, where you apply for the permission. You have also check NOTAM. This is if there is any traffic registered for the day you will fly. And when you get all these permissions, you say the exact area where you fly and you are ready to go. If there is, if you know that there are some people who will pass by, it's good to have signs and to aware them that you are flying there, so nothing bad can happen. On next stage, next step in the office is also equipment checklist. You must go really through all the equipment so you are ready, because once you go to the field, you have to work. There is no time because you can fly only when it's daylight, and so you must be really well prepared. You have to check the batteries, the cameras, all the markers, and drones, the propellers, everything. Also, when you come to the field, first things first, you have to check, you have to make a strategy to know who will fly, who will do terrain capture photos, and about interior, exterior, some details. The object you will scan, you must divide it on the parts. Each part must overlap to another one. This is the plan of flights, of capturing, but also the plan of setting markers, because usually there is a rule of thumb that each model has to have, let's say, lowest 5 markers, and they have to be on much photos as it's possible. So you start to setting these markers, but let's say in this example here is really too much of them. That's why you have to really well prepare or plan how to set them up. We know 2 types of markers that are mostly used. There are also other ones. Maybe you can just marker can be just painted by hand. So, but that will little make longer the process on digitalization. But we use the markers that are provided by the softwares, and we have 2 ones. One is 12 or 16 bits, which are used for details, and one that are the down, which are just for squares. These are cross markers, which are really they can be seen also from drone when you are really high, let's say 40 meters. These are used for orthophotos of the whole area. Yeah, and markers provide us through scale. We put them on different ground elevation, so we can get really precise accuracy of the whole model. Also, they help software to optimize cameras. Let's say, this is the example in Gorazda, the plan of where the markers are set. We see these cross markers are the 4-digit numbers, and the detail are the lower numbers. Like I said, there are minimum 5 markers, and they have to be spread evenly. It's really important that markers are seen from the let's say 36 degrees, but usually it's not like that, but you must place them. They are visible from most sizes, from most sides. Each marker is then measured by our server, so they get the correct GPS data, and they are also georeferenced by the coordinate system where you are taking photos. Let's say if you're in Slovenia, you use the Slovenian coordinate system. If you're in Montenegro, you use Montenegro ones. This will also, the help of these markers will also put the model in the right space if you put it in, let's say, like Google or some maps which use the coordinate system. Before you go to take photos, you have to set also the camera settings. It's most important for the camera. The most important things is aperture, because you don't want to put it in low values, because you will get depth of field, and this is not good for processing later. So you just put it on the upper values with low ISO, so you have less noise, and you go. The shutter speed depends on the lens you use. And for drone settings, it's really similar. Just here, the important part here is the shutter speed. You must keep it really fast, because with drone you are moving forward and backward, and you don't want the pictures to be blurred, so you keep it on really fast speed. Other settings are the same. When you fly with drone, you're doing some patterns. You say the orthophoto, the vertical, where you cover the whole area, the ring when you fly around objects. Then you just go to fly. There are some also with drones, you can also make first the low poly model of the object you're taking, and after with the low poly model, you make the mission plans, how the drone will fly, and they can fly also automatically, and with some overlap settings, say, because there is some rules. You have to keep the 70 to 80% overlap of each image. And yeah, when you're scanning, you also set your workplace in different sites, like in a church or a camper van. Depends where you're scanning, because on the field you have also do some checklists. You have to check the photos, if they are good, if there is enough overlap, if the weather if there are no shadows, much sharp shadows are not good, because on the texture it will be everything will be seen. And yeah, So that's why also it's better to check everything while you are still there, because you can later fix it. The vegetation can cause you really problems because you have to fly all over the obstacle and take much more photos that you actually need. This is the example of when it's getting frozen, the propeller of drones are icing. Also the photos can be these light beams, ray beams are not good for the photos. This is everything you have to check when you are on the field. And you have to eat also and drink coffee, a lot of coffee. This is everything from me. So, Jerne,
Yeah.
floor is yours.
Okay, thank you. I think I'll open my own presentation if you can. Stop sharing. Okay. There we go. That hopefully it's working. Okay, so what is photogrammetry as a method of capturing data? So photogrammetry is basically getting information about physical objects, physical object dimensions by examining and interpreting images you captured by matching their features. So you can think of it like a reverse photography process where usually in photography, you compress a 3D object to the image. But in photogrammetry, you turn a lot of 2D images into 3D objects. This works by the same process your eyes work to perceive depth by measuring the difference of movement of features on an object in different images, and by examining how much the features change position between images, the software or the algorithm can infer depth and create a 3D object. So like any method, photogrammetry has some good properties and some bad. So let's start with the good. It's very simple to start using photogrammetry for your own needs. It is very scalable, so you can do small objects or large objects. Non-invasive, meaning you don't have to physically touch an object. It usually helps if you put some markers on it for accuracy's sake, but in theory, you don't have to touch an object to capture it. It has a wide range of uses, like you can create archival data, you can scan an object and start creating 3D models, maybe print 3D models, make maquettes, or use them in renders and promotional material. That means it's reusable and shareable in product, so you can create a model, send it around to other people so they can process it in their own way, they can create their own products and further develop the model. And also it is as-is capture, meaning the pictures you take or the data you gather, you're going to get that same object back. So there is no changes. There is no room for artistic interpretation, which in a lot of 3D modeling there usually is, which also leads to the bad. It is as-is capture, so meaning you get what you take. So if you get a bad data set, you will also get a bad model. It is not suited for every type of material, per se. It really struggles with transparent and shiny material because it looks at as I said before, it looks at features, and if those features are hard to detect, the software won't know what to do with them. There are ways to work around this with special sprays or coatings that can make the object either opaque or rough, so that you don't get reflections. But that's one of the limitations of this method of capture, and it's very data dependent, as I already said. So bad data sets create bad results. So we in computer science, there's a nice term for this. It goes garbage in, garbage out. So feed bad data, you get bad results. So to get started with photogrammetry, for the basic user, you just need a camera or phone camera and some software. There's a lot of softwares, as we mentioned this before. My colleague mentioned a lot of them. Some are free, some are paid. Usually they all get the job done. The differences in how accurate you want the end product to be and in how much control you get over the creation process. For advanced capture, you need a lot more equipment like lights, soft boxes, and drones, and georeferencing equipment, like my colleague already said. And most importantly, a lot of data storage space. As mentioned, the photogrammetry softwares are becoming very popular in the past couple of years. But we use mostly in our company Metashape and reality capture. If we want to create an object fast, we usually use reality capture because it is a lot faster than Metashape. But Metashape offers a lot more control over the whole process and provides a lot more accurate results. But the trade-off is a lot more time spent on the project. So the basics of capturing data are very simple. You need to capture an object from as many possible different angles as you can. And so around an object and above the object, so from all directions. Usually we aim for about 80 to 70% overlap, meaning 80% of the object from one picture is visible on another. This is how it looks like in the Metashape software once it's aligned. So we take lots of pictures around one feature and align it, trying to get as much data as possible. We also do what is called an orthographic capture. So we can take, we can get the overview of the terrain, which helps with the alignment process of the images, which shortens the whole alignment process and also gives a little boost to accuracy of the model. So for pictures, there is the one of the most important thing is lighting. So we do not want hard shadows like from the sun, as you can see on the picture on the left. We want soft diffused shadows so you can see as much of the object detail as possible. We are not looking to take pretty pictures. We are looking for data. So the background of the image usually doesn't matter. So we are focusing just on the object. We also need to edit every single image so we can color correct it and get as a unified data set as we can possibly get. So we don't trust our eyes to do this. We use graphs and we use measurement devices. So we get uniform results. We gather as much data as possible. So we rather have too much data than too little because we can always delete, but we can't create new pictures. So this is an example of how we edit our pictures to create as much detail as possible. We usually look to get more information out of the shaded areas, where the software in a raw image usually can't see the details. Then we align photos. This is the process of feature matching. So we took the 90 to 80 to 70% overlap, and the software then detects similar points and aligns the images according to those features. That creates a point cloud, which looks a lot like this. Then we also use markers, as my colleague previously said, and we use the software's auto detect features to detect the markers, which also helps align the image. This basically works as another feature, which is more accurate than other features on the model. And also by measuring and georeferencing them, we get a lot more control and precision of at the final result. So this is how a early stage of alignment and point matching looks like in software. It's really it's not done yet, so it looks a lot. It looks chaotic. So once we have the images aligned, then we create a dense cloud. This is a further analysis of an image, which detects even more features and creates points in space, which we can then use to create the object. So point cloud, this project was around 32 million points, but the dense cloud created after alignment was about 285 million points. So almost 10 times as much, or actually more. Then these points are interpreted by the software and connected together by a process called meshing. And this creates a solid surface and basically creates our 3D model. This is the untextured version on the left and the final product on the right. We'll soon see how this is created. So we take the images we aligned and basically project them on the surface of the model that was created. And we blend between them, so it creates a texture on the model from the images. That's why it's also important to have really good quality images, so the textures come out looking great. And this is fairly simple to do in every software, but where it gets complicated is ensuring accuracy. So this is why we use Metashape, and we do a lot of these control points. So we have a lot of data, so we can reference all our data sets on that. So it is usually within 1 to 2 centimeters error deviation. It gets complicated with large objects because of large data sets. We have to align each part separately and then combine them together. This takes a lot of time usually because the data sets are large and you need quite a lot of computing power to align and process those data sets. As my colleague mentioned, difficult terrain and weather conditions are always a problem. you're fighting the weather and basically nature, so you got to plan accordingly. Flight automation. You have to be careful with flight automation. I think we have once accidentally flew one drone into a tree because we didn't plan carefully enough. Manual flying, so you don't hurt any other people, damage the equipment or the object. In limited spaces, like my colleague also showed before. But the largest problem, I think, is the large data sets you can get from these captures. Usually we're talking in multiple terabytes of data, just pure images captured on the field, which then also need to be processed and computed in the software. So again, problems. And this is one of the projects we did with photogrammetry. So we can see you can scale up massively, or you can do simple small objects like this. This is one of the more interesting projects we did. It combines point clouds and 3D models. So it's a nice combination of both. And that's it from my side.
Great. Thank you guys for this introduction into the work at field, I would say. Has anyone any question from participants? Slavisha, please go.
Hi, everyone. Interesting as always. Thanks for the presentation. Actually, I have two questions. The first one is about technology. So you use the photogrammetry, but what about the LiDAR technology and LiDAR-enabled cameras? Is that something that could be more efficient in the future and can be used for projects like this? Or the control and precision of photogrammetry is still, unmatched in especially in the open field and infrastructure like that? And the second question is about the best conditions to actually do the on-site photogrammetry caption. So, what time of the day or what kind of weather condition is most suitable, which in turn, saves you time in post-processing? That's it.
So to answer your first question, we actually like to use the combination of both laser scanning or LiDAR scanning and photogrammetry. The thing is, with laser scanning, it is cumbersome to carry the lasers around. You can't always get to all of the areas you want to scan. Technically, the laser scanners are more precise, but they don't offer as good as a texture capture or a color capture as photogrammetry does. So, and it is a lot more expensive. Usually the scanners are between the 500 and 200,000 euro range to buy. So it is quite an expensive technology still, where photogrammetry is a lot cheaper to get started with and to get comparatively similar results. But yes, we do like to use the combination of both if we can. And hopefully that answers your first question. About the weather conditions, it is usually best to go at overcast weather. So you don't have direct sunlight, which creates hard shadows. You want to have cloudy sky, so it diffuses the light, so there are no hard shadows. And time of day, ideally it is noon, but again, photogrammetry takes time to capture. So the best practice is that you get the job done as soon as possible, so the lighting conditions don't change much. But yeah, overcast weather and about noon, that would be the ideal condition.
Any other questions? Okay, then we have somebody. If I'm not wrong, Faruk, is you? Yeah, let's see, because the name was not, and I was like, geez, okay.
No, not being Zoom. And first of all, I mean, amazing. One of the most interesting presentations I've seen for quite a long time. I was really carefully 3D scanning, laser scanning it. No, I have a lot of questions, but I really have a lot of questions. But if you have other chapters to cover today, and then I can skip at the end. Maybe I can pose my questions, or if I can
No,
answer them.
actually, we wanted, because last time the discussion was so like good, that we wanted to leave time for the discussion. So go, like, we are here to.
I have a lot of questions actually. I mean, first of all, I'm really keen to also look into the first webinar, so I will be checking that as well. But these markers, I mean, Jernej and Luka, they quite nicely spoke about the importance of them. Though basically, Jernej said that we might not necessarily need those, but I think it's nice to have those as the reference for also distance from the object, especially if it is how to say, not good weather, and then something could be a little bit blur, and then yeah. I just wanted to. I have Jernej and Luka. I have many questions. Let me pose them one after another, and maybe you will be able to cover one after another. So one of the questions: are these just like markers in themselves, like as a visual item? Is like it might also have some GPS type of thing, like so that you can correlate it with real GPS. This is how, like like this iTech thing, just to point out where concretely it is located geographically, not with regards to the drone or to the camera. The second question: do you do that? It's not maybe needed, but you might also cross-check whatever you're capturing with GPS as such, like with Google Earth, with other things, like just to precise the location. Maybe at the end of the day, the way you present it is also linked to the map, so you might also correlate it with that. What I mean, I was looking through. Sorry, maybe my questions are not as how to say as technical as Slavisa's, but close to maybe to those. Another question is, you quite nicely shown how all these pictures are being basically turned back to the 3D, and the software you use. You also showed one software is doing it quickly, but you don't really have a control over the process, whilst the other one, the meta shape, is really allowing to control the process and also to ensure the better quality. I mean, it's just maybe my personal question. To what extent AI is also being used by these two softwares? Yeah, I know that the markers are making link and then putting it all to the 3 model, and then you basically have it as a final result. But do you think that AI is also there? I mean, maybe more from the reality capture side, because you don't really intervene into the process. You just allow everything to be merged into one, and maybe this is what they apply, AI. But maybe it's more, let's say, manually done by Metashape. So this is the third question. What was the soft boxes which was mentioned? I just wanted to know. And the fifth question is why you're not capturing the 90% angle, the right angle of, you said 85% or 80 when you scan it. The question number 6, I understood that you never count on the drone multispectral cameras. You better apply your more sophisticated maybe camera to the flying drone.
Yeah, sorry, you're cutting out with the I don't hear anything.
Can you hear me now?
A little.
Okay, but maybe you can
No?
go like with, yeah, now
No?
it's better, yeah.
No? Oh, sorry,
Oh,
sorry,
okay.
my microphone was up. My microphone was 90% off. So the question, the last question was, why you're not? I mean, you know, I'm flying drone myself. Yeah, I know the battery thing and everything, how long it is flying. Do you think that could be, if I understood well, that you're applying your own camera to the flying drone? Don't you think that it would be also of maybe for the sake of your activities, for lesser charging or lesser battery having with you, maybe to buy one drone which is having quite good camera, and then you don't need to carry extra weight, so maybe you can economize in time. And final question, sorry. You showed very well how you were correcting the colors, and yeah, basically. And then I understood why your 3D models are looking a little bit not so natural when you put it, yeah? That's why you're basically correcting all the pictures. But do you think that in parallel you can do the parallel model, 3D model, without correcting the pictures, and then that could maybe look more natural and more attractive, or more not attractive in a sense, but we also, I mean, all this project is done to attract tourists from the coastal area of Montenegro to, you know, to the remote areas, to the mountain areas. And sometimes they're looking at, hey, is it the man-built one, or it's really, I mean, is it like is it like augmented reality, or it's something real? So I think just having a copy, a twin of it with not unprocessed pictures would make it more natural. Sorry, I can stop here because I have other many questions, but maybe when we meet, I can extend that.
Okay, so the first question, I think you were talking about markers, right? So basically we use those markers because the software can auto-detect those specific types of markers in software. So we don't have to go in manually and place each one of them at specific locations. We do measure those markers specifically with GPS coordinates, and we place them, as my colleague said before, in their respective GPS systems. So we use Slovenian for Slovenia and Montenegro for Montenegro. And basically that means in software, it moves the markers at those coordinates. So if you use any application that uses your coordinate system, if you would put the final model, which is referenced into that application, it should have the same coordinate, it should be placed at exactly the same coordinates as the scan or the measurements of the markers were taken. So you have precise location of the object itself in your coordinate system. We usually don't do it ourselves because we don't have the equipment. We hire a professional to do it. Mm-hmm. So just to ensure accuracy. Yeah, that's about it. We can use anything basically as a marker, but these just help us to process the data sets faster because the detection happens automatically. Well, as for the MetaShape versus reality capture, as far as I know, there is no AI processing and the alignment of objects, feature detection. This is all just normal algorithms with no AI features. as far as I know, Luca, if maybe you know if any AI features were added to Metashape, but I'm not sure.
No, I also don't know, but there are some ways of. I think NVIDIA developed scanning with AI. So where there you have only 3 photos and it's guessing all the different sides of the object, and then it's making a 3D model of it. But we want to avoid this because we want to have the exact reconstruction, exact the duplicate. You don't want to guess what's between the photos. But yeah, I think everything will move also in the AI sector. Also, all these softwares, Metashape, Reality Capture, they're optimizing them by reducing the time you need to come from photos to 3D model, and they will use also AI definitely. But as for now, I also don't not aware of the usage. Probably you saw the photo where we have the 360 camera on the drone, but we are using the drones, the cameras of drones for taking photos. Yeah.
Let me just show you real quick. Let's see. So we're using drones like this with cameras on them.
Okay.
So we don't really put cameras on our drones except for some special task which requires
Fantastic.
a 360 camera or something.
Was
But that's
misunderstanding
usually
from my side. Yeah.
And we do 90 degrees orthophotos, 90 degrees and 45 degrees. The 70 degree, 80 degree you mentioned, you asked, it's the overlapped between the images. That's when you shoot another image. That's that there is. This is the rule how to make then the model because all the points must be calculated.
about 80% of the object is visible from the second image, and compared to the first one.
On the
we
last
get a lot
question,
feature points.
what was the last question?
There was a you capturing the pictures. Said that the ideal is where there is no shade, but then you're processing it to make it a little bit like less blur and more like and all this texture. I mean, it's turning from the multispectral analysis to textural analysis picture. But when you put it to the final, let's say, model and put it public, people have a look at this and looks like it's a cartoon. It's not so natural. So my suggestion was also consider to have a tween of it with naturally captured pictures, and then it looks like really how to say, like more. It's not to cancel what you're doing, but to have it also like a second.
Exact.
Yeah. Exactly.
No, we do it that because we want to keep all the shadows away, because later you can add lights with 3D softwares. So you can change those lights to, let's say, make it in really early in the morning with long shadows and warm colors, or make it dark. That's why we want to keep away all the shadows of the models. And yeah, the models looks maybe not so natural, but I think this is the why we do it like this.
Because usually when the model comes out of the software, it is not yet done. It requires further rendering, we say, in other 3D applications. So you can basically use it for other purposes than just as is capture. Because once you, we say in the industry, bake in all the lighting information like shadows, you can't really relight the model and use it in different lighting conditions, like my colleague says. If you have a scene with early morning, or create a video of it, whereas the sun is rising or something like that. You can't really use it because it would look unnatural. You would have like two sets of shadows, or we try to eliminate all the lighting information to have just the colors, so we can use the other software to create an end product which is specific to our clients' needs.
Thank you so much.
Mateusz, you want to?
Maybe just to answer to what was the last question and the last discussion. The Jernej and Luca already explained that we use these 3D models in different contexts. And in the next session, the next workshop that we will have, we will show how we use those 3D models, let's say, in different contexts. This is why we need them uniform in a way that we can later on adapt it to different weather conditions and things like this. And there are also two other reasons maybe why we avoid having all the shades inside it, because the photos, and maybe Luca and you may correct me if I'm wrong, the photos that we take are taken in a time span of a few days. So if we keep the let's say the shadows inside, it might happen that there will be more shadows in the 3D model than they are in reality, where it's only one, you know. And then the second reason maybe is also the 3D viewer. So the 3D models that we are showing to you, if it's interactive online, they need to be compressed to be shown online. And about 3D models, we will also talk in the, not the next workshop, but the one afterwards, where we explain how what happens with the 3D viewer, why you need a 3D viewer, and why a rendered video looks much more natural than a 3D viewer.
Great. Do we have any other questions?
I think there was one question before from Luca.
Yes, but then, yeah, exactly.
Hello, I have one question regarding processing of files. Do you have some connection to your HPC, or you are processing all files on some good machine, but locally?
Well, we use a combination of both. We use local machines for image editing. So all of the alignment all of the processing of images happens locally, but the calculation themselves, we use the HPC. We connect it, we upload the projects and calculate it on the supercomputer.
Okay, is that plugin on software which you use locally, or you have an application installed on HPC?
We have an application installed on the HPC, but the software supports a direct connection, so we can you can offload tasks onto different computers.
Okay, and can you tell us the name of this application?
This is Agisoft MetaShape.
Agisoft. Okay, thank you very much. Thank you.
Great. Any other questions? I actually have one, Luca, for you. So what would you say from on the field in Montenegro? How was, the week there? You can compare me with many other projects. Would you say were there any specifics, maybe some fun facts or whatever, just to give a little bit of, background of the experience there?
Yeah, there were a lot of tourists. But fortunately they came all at the end when there is down at let's say 5 p.m. when the sun were getting down. So we hang with them also on the rooftop with a nice view of the Kotor Valley. But if we say about the scanning, we had really couldn't do much for the weather or wait for the forecast or some clouds to came, but we manage the shadows, so we capture at the different daytime. So in the morning we capture the west side, so there were no shadows, and the east side at the end of the day. So we could get all the images without shadows.
So actually, one of the lessons is that the pre-planning is even as important as then when you are there. Otherwise, you come and you can go back home if you are not ready, if you don't know where to start, how to plan, how the sun is going, and all this stuff. It's like pre-planning phase is actually
it's really important. Yeah.
Okay, great. If there are any other questions,
maybe
otherwise,
couple of. So, Luca, then that means that you could have got the permission, right, to fly. It also is very close to the Kotor airport.
Yeah,
fantastic. Just also, I mean, I like the Lucas question. I mean, approximately, just so I have an idea, what is the size in terms of, I don't know, megabytes, gigabytes of this, at least Garage the Pro? I mean, what like what hard drive size we're talking about? Like, is it, does one project reach 1 terabyte or something?
Yeah, I think we are close to 1 terabyte. Yeah.
Oh wow.
Yeah.
Okay.
Now when I'm processing, I think at 25% of all the images, and I'm around 5,000-6,000 of images. Yeah.
I mean, all these questions, sorry for that. I can see that this project, this digital solution is also a product of fusioning different technologies. You have the 3D, like 360 degrees, like, a little bit of AI. I'm now looking, someone put to the chat this Luma AI thing. I'm just looking into that. So we're also looking here at UNIDO, we're looking at this type of technologies also as inspiration to address other than tourism, for example, purposes. But whatever you're doing is very, very interesting. I might knock on your door one day to see how we can fusion with other technologies. I mean, I think Yerny just replied that agro software is basically being used, like agricultural or like smart agriculture. Dedicated software is being applied for, capturing information, etc. So, yeah, definitely there could be something for the environment, for agriculture, for city planning, and just to have a few ideas. But thank you so much. I would like to thank you and to really be thankful for very, very, very interesting and presentation. I would be keen to join the next editions and also to look to the video of the first one. Thank you.
Great. Thank you. Anyone else? Otherwise, Luca, your name, maybe can you just reshare the last slide with the webinars, one of you, please?
Yeah.
Perfect. So just to remind you, you already registered, but like that's next week, and then we have other webinars coming. If you have any questions, please don't hesitate, just share per email. We already answered them some, and if you have some really ideas or suggestions what we should include in next webinars, please share with us, because as you can see, we really put in what are you interested in. As we already mentioned, Mateusz mentioned at the beginning, next time we'll be together in cooperation with a local project, so stay tuned. And yeah, that's it from our side for today. Thank you for your attention. We are very happy that you find it interesting and that you have so many questions. So I hope this interest will keep also in the future. Thank you, Luca and Jernej, for today. It was really inspiring. And yeah, have a nice day. Thank you to everyone. See you next time. Bye.
Bye.
Bye-bye.
Bye bye. Bye.